Hello everyone, welcome to this particular lecture. Today we will discuss about the equipment in a transformer substation and smart grid. So previously we have already seen what is a substation. Substation is nothing but it is a facility that can manage or control the voltage levels. Okay, and they will direct the power flow. And what is a bus? Bus is nothing but a connection point or a junction or hub in the substation. Okay, that will link different lines together and electrical components together. So, what are the basic functions of a substation? Why do we need to use substation? The main function of substation is to step up and step down. What is that? Electricity it is getting generated at the power stations using the power plant. Okay, now, and that voltage is 11 kV, but that voltage is stepped up to 440 kV, and that is transmitted through a high voltage transmission line, and finally in various through various step down transformers located at various substations, we finally use in our home a 220 volt to 230 volt single phase supply. If for industries it is used, we need to use a 440 volt three phase supply. So the main function of the substation is step up and step down. If we need to increase the voltage, that can be done using the step up transformer, and if we need to reduce the voltage, that needs to be done using the step down transformer. So these step up and step down transformers are located in the substation only. Next function of the substation is metering. What is metering? I have already told that the electricity it is generated in the generating stations. So let's say Tata, then Adani, then Reliance, they are generating the electricity and they give that electricity to the power grid and national grid. Okay, so this generated electricity, uh, this can be generated by the private companies, and the transmission line they belong to the government. So how much electricity Tata is giving to the government, that is measured in the substation. So this power plant, how much they are giving the electricity to the government, that is being measured in the substation, that is called metering. So this is the second function of the substation. What is the third function of the substation? It is called load balancing. What is that? Suppose in the power station, 1000 watt electricity it is getting generated. Okay, so among that 1000 watt, let's say 750 watt is going to the city, and rest, let's say 200 watt is going to the village. So 750 plus 200, it is around 950 watt we are using, or we are distributing in the village and the city. Now let's say if there is a sudden demand in the electricity in the city, let's say it now needs not 750 but 850 watt. So in that case, what will happen? 850 plus that 250. So 850, so 950, then 1050, 1100 watt. Okay, but the generating station is generating the power at 1000 watt, but the demand of the electricity is 1100 watt. Okay, so due to that the generating station will get overloaded, and the circuit breaker, I will come to this specific term circuit breaker later when I discuss the substation equipment. So the circuit breaker in the substation it will open, and the that electric supply, that electricity supply from the generating station will get stopped. So in that situation, neither city will get the electricity supply nor village will get the electricity supply. And in that case, sometimes in order to fulfill the city electricity demand, the electricity supply in the village is being cut off. That is why there is some electricity fluctuation happens in the um, village. And this electricity cutting and providing that electricity to the city, those operations are also being carried out in the substation. So this is called the load balancing. So this load balancing operation is also done in the substation. Next function of the substation is safety and power quality. See, the in the electricity in the power station, in the generating station, electricity it is generated at 11 kV. Okay, now that 11 kV straight away at one go we don't use in our houses. Okay, finally we are using in our houses 220 volt, but that electricity we are not directly using in our houses. Okay, even though we are having, let's say, a very long transmission line, 200-kilometer long transmission line, we are not using that 11 kV generated electricity using that 200-kilometer long like transmission line. In between we have different substations, because let's if there is some fault in that long transmission line, so in order to fix and doing the maintenance of that transmission line will be very difficult. Okay, so also, like, if there is some fault in the transmission line, sometimes if the transmission line is very long, let's say if it is 200-kilometer long transmission line, then sometimes the power factor in the transmission line may get reduced. Okay, if the power, because these transmission lines and distribution lines, they are overloaded with the inductive loads. Okay, due to that the power factor in the transmission lines, that is always get reduced. Okay, but we need to improve the power factor. Okay, so how that power factor can be improved, we need to use the shunt capacitor banks in the transmission lines. Okay, now if we use the shunt capacitor banks in the transmission line, they usually located in the substations that are near to the load. It will increase or it will improve the power factor of the transmission line. Once the power factor of the transmission line is improved, then what will happen? See, if the power factor is high, the current in the transmission line will be low, and if the current in the transmission line is low, then in that case the loss, I square R energy loss as heat through the transmission line will be less. Okay, so this is the reason we need to improve the power factor of the transmission line. Okay, so this is the fourth function of the substation, which is safety and power quality. So these are the four functions of the substation. First one, step up and step down. Second one is metering. Third one is load balancing, and fourth one is safety and power quality. Next, we will come to the substation equipment. So in the substation equipment, we have the main part of the substation equipment is the transformer. It is the heart of the substation. It is a king. Transformer is the king in the substation. So the main function of the transformer, we know already. If we need to step up the voltage, we will use the step up transformer in the step up substation. If we need to reduce the voltage, then we will use the step down transformer in the step down substation. Okay, so all other equipments that are there in the substation equipment, that are there to ensure that the transformer is performing well and it is working safely. So that is the main function of all other equipments. So this is the transformer. Then just at the two adjacent sides of the transformer, we have the lightning arrestor. This is one lightning arrestor, this is another lightning arrestor. In short, we will call it LA. What is that? Suppose during the thunderstorm we have lightning, right? So due to that, if like suddenly the voltage in the transmission line gets increased, that voltage will also come in the transformer, and your transformer may get damaged. Okay, so what is the job of this lightning arrestor in this case? Lightning arrestor, if suppose if voltage more than the rated voltage comes in the transmission line, so lightning arrestor will ground that voltage and provide protection to the transformer. Suppose the transmission line voltage is 132 kV, and that voltage due to the lightning comes on the transmission line is 300 kV. So this lightning arrestor will ground that 300 kV voltage and will protect the transformer. What is the next equipment in the transmission line? Next equipment is a circuit breaker. We can see this is one circuit breaker, this is one circuit breaker, this is one circuit breaker. So this is another circuit breaker, this is another circuit breaker. So circuit breaker, it is basically an electromechanical switch. So what is that? Like sometimes in the transmission line of the transformer, what happens, very high short circuit happens or overload condition happens. So both of these case, high current flows to the transmission line. Okay, and the equipments that are connected to it, it might get damaged. Okay, so what in that case, what a circuit breaker will do, as I said, circuit breaker, it is nothing but a electromechanical switch, and it has two parts. One part is the fixed contact. It has two contacts, rather, not parts. Fixed contact and the moving contact. Okay, this fixed and the moving contact, they are like separated by a dielectric. Okay, so suppose whenever there is a short circuit or overload happens, or some fault is detected in the transmission line, then this fixed part and the moving part, like whenever the fault is detected in the transmission line, the circuit breaker will feel the necessity to release the stored potential energy in it. So how it will release that stored potential energy? By separating the fixed part, fixed contact and the moving contact. Okay, so when the fixed contact and the moving contact is separated, during this process a conductive or some conductive arc or ionized plasma is generated. Due to that, some heat is produced, and that due to that, that conductive plasma or the arc is generated, right? So due to that arc, the circuit breaker, it tries to extinguish that arc. Okay, it tries to quench that arc. So as a result, it needs to separate out that two contacts. Okay, so in that case, circuit breaker will act as an off switch or open switch. Okay, in that case, no current will be able to flow through the electric circuit, because we know when the current needs a closed path to flow, when the circuit breaker is open, the current cannot flow through the electric circuit. Okay, this is how the circuit breaker will be able to provide the protection to the transmitter and transmission line and the transformer. Once the fault is cleared, that fixed and the moving contacts, they will be again, uh, they are joined together, and the circuit breaker, it will go back to its reset condition or normal condition, and current will start flowing back through the electric circuit again. Okay, so this circuit breaker, it is an electromechanical switch. Whenever there is a faulty condition in the transmission line or the transformer, it will make the current zero. Okay, and all the equipments that are connected to it, it will make sure that they are safe. Okay, now, so as I told, the circuit, I'm repeating once again, the circuit breaker, it has two parts. One is your fixed contact and another one is a moving contact. Okay, now whenever there is some short circuit or overload happens, both due to both of these conditions, high current flows to the circuit. So in that case, some fault is detected by the circuit breaker, and circuit breaker feels the necessity to release the potential energy stored in it. So in order to release the potential energy, it needs to separate the two contacts. Okay, and during this process, some conductive um, plasma or ionized plasma is generated, which is called arc. And as a result, circuit breaker will try to extinguish or quench that arc. Okay, so due to that, circuit breaker needs to turn off or act as an open switch, or it needs to separate that two contacts. So as a result, the current in the electric circuit will become zero, and when the fault is cleared, the circuit breaker will go back to its normal reset condition. That fixed contact and the moving contact will be connected back together, and the current will start flowing through the circuit again. So its main function is to make the current zero whenever a high current is flowing through the circuit. Next component is the isolator. What is this isolator? You can see this is one isolator, this is one isolator. So these isolator also acts like a switch, but it is a mechanical switch. And this circuit breaker, it also it is an electromechanical switch, and it is an automatic switch. Whenever the fault is detected, it will act as an open switch, and automatically it will make the current zero. But isolator, it is a manual switch. Okay, and it is a mechanical switch, it is a manual switch. So what this isolator will do, it will disconnect that faulty section of your electric circuit from the main supply. Now you can tell that is what was circuit breaker was doing. But the circuit breaker main function was, whenever the current was very high through the circuit, it was making the current zero. Okay, but making the current zero is not enough. Suppose you want to there is some fault in the transformer, and you want to have a maintenance in the transformer. Okay, so when the electrician comes, first he will make sure the current is zero through the circuit breaker, but that is also not that won't provide you the 100% guarantee that the line is all the supply is off. So because even the current is zero, still some static charge will flow through the electric circuit. So when that electrician touches the wire, the static charge directly flows through his body and goes to the ground. Okay, so and some accident may occur. So in that case, we need to use the isolator. This isolator, what it will do, it will disconnect that faulty section from the main supply in order to safely repair them. Okay, so this is the main function between the isolator and the circuit breaker. First, we need to turn off the circuit breaker, or we need to make sure circuit breaker is open to have the current zero. Then we need to make sure we need to use the isolator. This isolator, it will disconnect that faulty section of your electrical circuit from the main supply, right? Next, we have this current transformer here. CT is the current transformer. What is it? This current transformer, it provides the protection to the transformer and the transmission line. So it is not like the regular power transformer which is used to step up and step down the voltage. Its main function is to provide the protection to the transformer and the transmission line, and this current transformer CT is a step down transformer. Okay, suppose if I'm telling the rating of this current transformer is 100 by 5, that means the primary side of the current transformer, it is having a high current of 100 ampere, whereas the secondary side of the current transformer having a current of 5 ampere. That means the output side the current is 5 ampere. That means the secondary side of this current transformer, it is able to reduce the current by a factor of 20. So next we have this CVT. CVT, you can see these are the CVT components. CVT is a capacitive voltage transformer. So this CVT we use like as a replacement of the PT or potential transformer. So when the substation is more than 132 kV, in that case we use the CVT. Okay, this CVT is a step down transformer. So when the substation that is having voltage more than 132 kV, we use this CVT. Otherwise, when that voltage is less than 132 kV, suppose we want to convert 66 kV to 110 volt, okay, for that we will use the potential transformer. Okay, so the CVT, PT, these are all your step down transformer. That means number of winding in the primary is higher than the number of windings in the secondary. Okay, now apart from that, we have the overhead lines in the substation, we have the ground wire in the substation. So what is the function of this ground wire? During the thunderstorm, when that lightning occurs, the voltage, it will ensure it doesn't directly fall on the live wire but on the ground wire, so that it can transmit that voltage to the ground. Apart from that, we have this red color like bus bars. So these bus bars, they are just connecting wires. When many wires, they are having the same voltage, so through the bus bar, it is an aluminium or copper conductor, they will be connected together through this bus bar. So these are the main components or equipment of your substation. Okay, let us move on to the next part, the key diagram of a 11 kV to 400 volt indoor substation. So we all know, by far we have so far we have learned that the electricity, it is generated at the generating station at 11 kV voltage. Okay, now as I told, if there is a fault in the transformer or transmission line, for that first we need to turn off this circuit breaker. We have here this 11 kV oil circuit breaker. What is this oil circuit breaker? I already told you guys that this circuit breaker, it has two parts. One is your fixed part or fixed contact and the moving contact, and this fixed and moving contact, they are separated or isolated by a oil as dielectric. Okay, so as I told, whenever the fault is detected, then there will be some ionized plasma or conductive arc will get generated, and due to that, that circuit breaker, it will try to extinguish that arc. Okay, and due to that generated arc, some heat is generated, and that heat is evaporated in the oil as a dielectric, which is separating the two that fixed part and the fixed contact and the moving contact of your circuit breaker. So whenever there is a fault in the transformer or transmission line, first this circuit breaker will be opened. Okay, then once the circuit breaker open, that means we are now sure the current in the circuit is zero. After that, this geo switch is a gang operating switch, it is isolated. Then this isolator will disconnect that faulty part from the main supply. Okay, so here if you are using a three-phase supply, and this gang operating switch, here for each phase we are using one switch. Okay, so when many switches are operating simultaneously, we are calling it as gang operating switch, or these are nothing but the isolator. So obviously this isolator, it will disconnect the faulty part of your circuit from the main supply if there is some fault. Then that 11 kV supply, it is given to the cable box, and that is transmitted, that 11 kV voltage is transmitted through the transmission line. And this transmission line, here using the underground cable. We have already seen that in the city areas we use the underground cable as a transmission line, which is nothing but an insulated conductors. Okay, so on the conductors made up of copper and aluminium, we are providing some rubber or plastic coating. Okay, in order to provide the safety from electric shock. So this is another point of the cable box. Then that voltage, 11 kV voltage, it is coming out. And like if there is some fault in the transformer and the transmission line, then this oil circuit breaker, it will open, the switch will open, and it will make the current zero. Then we have a current transformer, it is there to protect the transmission line and the transformer, and the rating of this current transformer is 50 is to 5. That means the primary winding, the current is 50 ampere, and the secondary winding of the CT, the current is 5 ampere. Okay, now we are giving the voltage to the step down transformer. Here the number of winding in the primary should be higher than the number of winding in the secondary. This is a step down transformer in your substation. So the rating of this step down transformer is 1 MVA or 1 megavolt ampere. Okay, so after this step down transformer, what it will do, it will convert that 11 kV to 400 volt. This 400 volt, it is a three phase supply. So if some industries or factories, they want to use this 400 volt, we can directly give them. Then we have another main oil circuit breaker. Then after that we have one current transformer with rating 1200 by 5. So after that you can see this is a 400 volt bus bars. From here we are distributing the 400 volt voltage to the different consumers. Okay, now if you can notice here, the voltage is 400 volt, the output of the step down transformer is 400 volt. Then why this current rating is 1200 by 5? See, when the voltage is low at the secondary of the transformer, obviously the current will be high. So for that we need to use a high ratio current transformer. Okay, and if I want to disconnect this electric supply to these consumers, we need to cut this from this cut this supply, this 400 volt supply, from this main oil circuit breaker. That means when this main oil circuit breaker will be turned off or it will become an open switch, none of these consumers will get the electric supply. Okay, so if you see here, the rating is 1200 by 5, but here if you calculate, it is 200 is to 5. So here the current is 200, 200, 400, and here 200, 200. Let's say it is also like 400. So 400 for plus 400, 800, but here the current transformer rating is 1200. Okay, so the entire rating of the transformer, it is not used by these like consumers, right? So because 75 to 80% only we use. Okay, you can see that 400, 1200 minus 800, that 400 uh, ampere we are not using, as we cannot use the 100% rating of the transformer. So if we want to stop giving supply to these consumers, we need to open this main oil circuit breaker. So this is how this we can convert this 11 kV to 400 volt uh, indoor substation. This is the single line diagram of this 11 kV to 400 volt indoor substation. Next, this topic is actually this is not substation equipment. This is actually smart grid. Okay, the topic name is smart grid. So let me change here also. This is smart grid. So this is smart grid. So what is the difference between the traditional grid and the smart grid? In traditional grid system, one way electricity flows. That means here, let's say here we have the generating right side, we have the generating station, we have different power plants where nuclear power, thermal power, wind and solar power plants are there. They are generating the electricity, and here at the load side, like we are the consumers, we are getting that electric supply. So this is what used to happen in the traditional grid system. But suppose 100% electricity is supplied from these generating stations or these power plants, but that 100% it is not consumed by these consumers. Let's say some 73% or 70% is consumed. Rest of the electricity it is getting wasted. Okay, so now a concept called smart grid is coming. What is that smart grid concept? Uh, in the smart grid system, actually, like not only the electricity is flowing or coming from these power plants to the consumers or load, but like it this after consuming that electricity, it will also, these consumers also will be sending another information to these power plants or the generating stations. Okay, so based on that, based on at which time the industry is having peak load, how does the load varies according to season, how the load varies, how much power is consumed in morning and evening. So due to that, based on these, this load will be sending an information to these electricity providers. Okay, so at the load side we will be having the sensors and the smart meter. Okay, so they will continue to sense that how much is the load, when they will need that electric supply. So they will accordingly sense that and will provide the information to that generating stations or the electricity provider. So here two-way communication is happening. First is from these electricity providers, the electricity is coming to the consumers, and at the same time the consumer is providing the information. They are sensing that electricity, and they are sensing like when the load is high, when the electricity demand is high. Accordingly, they are also sending another response to this electricity provider. Okay, like this is actually done in terms of the tariff. TARIF. What is tariff? Tariff is nothing but a rate at which the consumers they are charged for the electricity consumed. Okay, suppose at different, like when we get the electricity bill at the end of the month, we pay how much we are like how much we are consume the daily electricity. Okay, based on our daily electricity consumption, we pay that monthly electricity bill. But we don't get the information from that electricity bill that how much like at different times of the day, obviously the electricity consumption is not same. Okay, so I already mentioned one term called tariff rate. So suppose morning time tariff rate is 2.5 rupees, it is low. Evening time it is, let's say, 4.5 to 6 rupees. Night time it is again 2.5. So if the consumers come to know that what is the tariff rate, then accordingly they can use the, or they can consume the electricity. Okay, morning time they can like increase the electricity consumption. Evening time when the tariff rate is high, they can reduce the electricity consumption. Likewise, they can also control their electricity consumption, and accordingly they will send that information to the electricity provider. In that case also, electricity consumption, maintaining that electricity consumption is possible. So that is the main advantage of your smart grid system.